Okay, for those of you who weren't here for the addition and substitution reaction lessons, or you'd like to recap it before your exam, welcome. I'm just going to go over what we did in the lesson with a few examples. I'm first going to do addition reactions on their own, and then we'll move on to substitution, and then complex addition, which a lot of people weren't there for, so I'll go into detail on that one. So basic addition is when a substance is added at the double or triple bond of an alkene or an alkyne. So I'll just make a few notes as I go. Or an alkyne. So the reactant is a double or triple bond, meaning if you look at a reaction where you're given the reactant and the product, you can identify it's an addition reaction because the reactant has a double or a triple bond. So if it's a worded question, it would be an ene or an ine. And then your product, so what you have in the end, is simply just one thing, and it will be an alkane. So I'll just write that. It's important you can remember these to identify addition reactions, because you won't always just be asked to complete this addition reaction. You might be asked, what type of reaction is this? And our product Okay, so there are two types. The process is exactly the same, but it can either be addition with hydrogen or addition with a halogen. So with hydrogen, it's simply just H2, or with a halogen, it can be Cl2, Br2, F2, we'll use Cl2. So first, I'll do addition with hydrogen. That was an interesting line. Addition with hydrogen, or H2. So I'm going to use butene as an example. So I'm drawing it out in full form like this rather than a line or stick drawing, because when we're talking about reactions, it's a lot easier to have it drawn like this because you can actually see what's going on and what's moving where and what we're breaking. It makes it a lot easier. So I suggest for you as well in your exam to give the best explanation you can, that wherever possible, regarding reactions, you draw a full molecule like this. So plus H2, we write it like this, again, written out fully rather than just H2, so we can see that bond. So, what are we going to get? In an addition reaction, the substance is added at the double or triple bond of an alkene or an alkyne. Here we have an alkene. We're going to break this double bond. Oh, you can't see those colours, that's okay. I'll do some underlining. So it's still going to have 4 carbons, a number of carbons don't change, and still all of the same hydrogens we had before. However, this time, we no longer have a double bond here, meaning this carbon's only attached to 3 things, this carbon's only attached to 3 things. We need to add our hydrogen here for that 4th thing. So this hydrogen and this hydrogen are going to simply get added there. There's no byproduct, this is our final product because we haven't taken anything away from this molecule. All we've done is broken a double bond. In substitution, which we'll cover next, we are taking something away and it needs to go to a byproduct. So that's another way that you will know it's an addition reaction and not a substitution reaction, is there's only one thing at the end. In the product, I should say, in scientific words. So what we had was butene, added hydrogen, and it gave us butane. So again, seeing that it went from an ene to an ane confirms that this was an addition reaction. Now, our second type that I spoke of, addition with a halogen. In this case, we'll use chlorine. This time, I'll use ethene. So we're starting with an ene again. We're going to add chlorine. So 2 chlorine molecules. Now, we're breaking this double bond, meaning those carbons need something else coming off them. Keep our H's as they were. Now we're simply going to take these chlorines and place them here. So we started with a double bond here, being an ene, and over here it's going to be an ane. So again we know that that was an addition reaction.